Hello again. We're going to be graphing quadratic functions again, and we're going to start with its parent function, x squared, and we're going to tweak it up a little bit. Basically what I mean is, we're going to see what happens when you add 2 to it and when you subtract 2 to a quadratic function, how that affects the graph. Now, if it doesn't have a 6x or a 2x or a negative 5x or negative x, then your middle value for your table is 0. X squared doesn't count and a number by itself doesn't count. If you have those two, then it doesn't affect the vertex, the middle point of a quadratic function. As long as you don't have that, your middle value is always 0. So, middle value is 0, so what you're going to do is have a 1 and a 2, negative 1, negative 2, and hopefully I won't make the same mistake where I call that a 2 this time again. So we'll start with the first one. I'm going to go ahead and do this. You can do this too. Just punch it in, or right here is fine. 0 squared is 0, 1 squared is 1, 2 squared is 4. Negative 1 squared is 1, negative 2 squared is 4. 0 squared is 0 plus 2 is 2. 1 squared is 1 plus 2 is 3. 2 squared is 4 plus 2, which is 6. That's a 3 without even checking, and that's a 6 without even checking. Maybe you notice what the 2 did to the table as well. It added 2 to each value for the y. So what do you think the 2 is going to do here? Well, 0 squared subtracted 2. You know what, I'm not going to even look. I'm just going to subtract 2 from here, and hopefully it'll be right. The answer is it will be right. And then that's a 2. That's a 2. And that is a negative 1. Just look right there. Didn't even figure them out in my head. Just looked at the values and was able to go ahead and see that. Oops, I think, yeah, that's fine, pardon me. I was a little afraid there, but nothing to be afraid of. So, I'm going to graph the first one in blue, y equals x squared. It's the parent function. One, two, three. And that's what the parent function looks like. It looks like a U, kind of. The vertex is the lowest point of the graph, and it goes up to infinity. Now, let's do the second one in, let's do it in green. As you can see, it looks very much like the first graph, except you've raised the vertex, or the starting point, up 2 spots. And let's do the third one, in brown. Again, looks similar, except you start out 2 places below. Obviously, everything's not drawn perfectly to scale because, well, I can't draw perfectly. But what I'm trying to say is that if you add a number to it, then the vertex starts at that specific number. So it's going to start at 2. If you subtract a number to it, it's going to start wherever that vertex is. Now that's different if you have a middle term. But if you just have this and this and this and this, that's the shape the graph takes. This number will always stand for the y-intercept, though. That's a given. This will always intercept the graph at 2 for the y-axis. This will always intercept the graph at negative 2 for the y-axis. And this will intercept the graph at 0. That's a given. That doesn't change no matter what the quadratic function is, which I think is pretty fascinating. Now, when it comes to domain and range, for the blue one, the domain goes from negative infinity to infinity, and most of the graphs we've done have gone from negative infinity to infinity. Linear, this, bam, bam, yeah, the good majority of them. And the range goes from 0 to infinity. Actually, that is a closed bracket because it includes the number 0. For the green one, the domain goes from negative infinity to infinity, but the range goes from 2 to infinity, because its lowest point is 2 all the way up. And for the last one, the domain is from negative infinity to infinity. And the range is negative 2 all the way up. Sorry, that's a closed bracket. The vertex for this one is at 0, 0. The vertex for this one is at 0, 2. The vertex for this one is at 0, negative 2. The axis of symmetry, where it cuts the graph in half, is on this line. If I want to cut any of these graphs in half, that line is right here. Now we will be doing examples where the graph will be shifted, but we're just working with this for right now. That's a basic understanding. We'll try one more aspect. Instead of working with numbers after the x squared, we'll see what happens when you put a number before the x squared. But until then, have a great day. Goodbye.